6.2 is about kites and trapezoids, and your learning target is for you to be able to use what you know about triangle congruence to understand and know things about kites and trapezoids. So our first theorem is stating that the diagonals of a kite are perpendicular. So that is just a known fact that the diagonals of a kite, or the lines that connect the opposite vertices, are perpendicular. Reminder that a kite means we have two sets of congruent sides. We've got these two sides are congruent, and these two sides are congruent, but they're not congruent to each other, as then they would all be congruent, and that would be a square. This is a kite. So let's dive into that theorem of what we know about kites. So in this example, quadrilateral PQRS is a kite. They tell us that. That's good to know. With diagonals QS and PR. So we have three unknown angles that we are going to use the information that we are given to find those missing angles. And since we were told that this is a kite, that makes part A pretty straightforward. Using that theorem that we just learned is that this measure of angle 1 has to be 90 degrees because this is a kite and the diagonals of a kite are perpendicular. So now let's use this information to find our other missing angles. We then want to find the measure of angle 2. And what I'm going to do is I'm going to draw this triangle a little bit bigger above it so we can find the measure of angle 2. This is T, P, Q. We know that this is 90 degrees because it is a kite. We are given that this angle is 35 degrees, and we want to find this missing angle 2. Well, since we know 2 out of the 3 angles of the triangle, we can find the missing third angle because we know that all angles have to add to be 180 degrees. So we know the measure of angle 2 plus 35 plus 90 has to equal 180, and we can combine those like terms and subtract, and we can find that the measure of angle 2 is 55 degrees. All right, our last unknown angle is the measure of angle 3, and it is on the other side of our kite. So now take a second and look and take a just guess of what do you think the measure of angle 3 is. You're going to use what you know about triangles that we learned last semester. Here's my hint. Let me draw half this kite and see if it jogs our memory. We know that this is P, R, I could put T here, I'm not going to, with Q. We know that this side is congruent to that side. We know that this angle is 35 degrees. We know that this angle 2 is 55. That doesn't really help us find this missing angle 3. Okay. Let's see, what do we know about triangles that have two sides that are congruent? Well, they are isosceles triangles. So that means that their two opposite angles are congruent. So that means that this angle QPT is congruent to this missing angle 3. So that means that the measure of angle 3 is also 35 degrees. Had to remember a little bit about isosceles triangles and had to visually see that even though this is a kite, it's actually just two isosceles triangles, one here and one on this side. You might need to know that moving forward. Let's move on. Our next theorems are about trapezoids, which is the second half of this lesson. So let's just remember that a trapezoid has two parallel lines with two congruent sides, but not necessarily the bases aren't congruent, because then it would be a rectangle. So in an isosceles trapezoid, each pair of base angles are congruent. An isosceles trapezoid is going to be when these two sides are congruent. The base angles, what we call these base sides, are also congruent. So BAD is congruent to CDA, and ABC is congruent to DCB. Okay, good to know. And the next theorem is that the diagonals that they create are congruent. So these two diagonal segments are going to be congruent. Our last theorem is how to find the mid-segment, which just means middle segment. So a segment that's drawn in the middle of a trapezoid. So in a trapezoid, the mid-segment is parallel to the bases. So all of these are parallel to each other. And the length of the mid-segment and mid-segment means we truly divide these two side segments in half. And you're going to see in this chart how we've got these, we note that with our congruence marks. So to find the length of the mid-segment, it is half the sum of the length of the bases. And you can use this formula down here, but I like to write it just as 1/2 B1 plus B2, which just means base 1 plus base 2. Let's use these theorems. So given this trapezoid JKLM, we want to know what KL is. So let's look at that. KL is actually part of the base. They give us the mid-segment and another part of the base. So when we're thinking about our formula that the mid-segment is equal to 1/2 base 1 plus base 2, we have enough information to figure out our missing part. Let's label what we know. We know that the mid-segment is 25. We know that base 1 is 4/5 xy. And we do not know base 2. That is actually what we are trying to find. But we can set this up as 25 equals 1/2 base 1, which is 4/5 xy, plus our unknown. We can label it KL since that's what we're actually trying to find, KL. And we can work to solve this equation to find our unknown. So if we're actually trying to solve this to find that unknown, we need to first replace what we know xy is so we can get that other unknown out of there. And xy is that mid-segment of 25. So let's do that substitution. And we're going to have 25 equals 1/2 times 4/5. Now substitute that 25 in there for XL plus the actual unknown KL. 4/5 times 25 is 20. So that is 25 equals 1/2 times 20 plus KL. And now we can really get into solving. I'm going to divide both sides by 1/2, and 25 divided by 1/2 is 50. So we get 50 equals 20 plus the unknown KL. Subtract that 20, and you're going to find that the unknown base is 30. And that's how we could use that mid-segment theorem to find some missing information. That's Kites and Trapezoids, and you guys are going to go kill that target.